So now we have seen an example of a virtual function. A function can be made virtual by writing the keyword virtual before the function prototype. That is this thing. Okay. So virtual function is a member function that is declared within the base class and it is redefined by a derived class. In the example, the base class contained the show function. Okay, so we made this show function virtual. So the virtual function is declared within a base class, right? And this virtual function is redefined by a derived class. So in the derived class, we redefine the show function, right? The virtual function within the base class defines the form of the interface to that function. So this virtual function, it tells that what kind of interface this show function will have. Interface means what will be the return type, what will be the name, and what will be the arguments. As I told you earlier that when you redefine a function, the interface or the function prototype or the function signature, these are all the same things. They remain the same. Okay, so it will remain the same in all the derived classes. Each redefinition of the virtual function by a derived class implements its operation as it relates specifically to the derived class. So interface is same but the function body changes. Function body changes according to the requirements of the derived class. Okay, so in the base class we printed base class, this string in the function body of show function, and in the derived class we printed derived 1. In the derived 2 class the same show function printed derived 2, right? So the interface remains the same while the function body or the function definition changes. So we can say that redefinition creates a specific method. So now it means that this show function in derived 1, it is specific to derived 1 class. This show function is specific to derived 2 class. Okay. So let me erase the ink. So when accessed normally, virtual functions behave just like any other type of class member or class function. Okay, so if you try to access a virtual function normally, right, for example, in the previous case we created the base class. So let us create base class object b, and then you write b dot show, then it will print base class. It will behave normally just like any other function. Okay, because we are accessing it normally. We are creating an object of base class and then using that object and dot operator we are calling this show function. Although this show function is a virtual function, but because we are using it normally, we are accessing it normally, it will behave normally like any other member function. But however, what makes virtual functions important and capable of supporting runtime is how they behave when accessed via a pointer. Okay, so how we achieve runtime polymorphism? We achieve runtime polymorphism or runtime binding through virtual functions. Okay, but when virtual functions are capable of supporting runtime binding, when they are accessed via a pointer. When they are accessed normally, they are not able to support runtime binding. Here only compile time binding will happen, no runtime binding will happen. Okay, runtime binding will happen only when you access some function, virtual function, through a pointer. Okay, BP arrow operator show. Here BP is having some address. It can have address of derived class, it can also have address of base class. Okay,